Hello everyone. Today I'm going to talk about my app which will prove very simple lemmas in a way that makes it clear what's happening. Here we have the proof state which says what we're trying to prove. For all x and for all y and all z, which are metric spaces, and given two functions which are continuous, can we prove that their composition is continuous? The idea of automated reasoning is that we can perform a series of simple moves on this state to eventually solve the problem. I've chosen the moves up here, and I've chosen them in such a way that they roughly correspond to what a human might do when faced with a similar problem. This means that we can generate convincing write-ups of the process. When I click run, it will try move 1 and then move 2 and then move 3 and then move 4 until it succeeds, and then it will stop. So as I click run, it will apply one of these moves every time. So 1 didn't work, but this one works, and this one will keep working. Okay. So now I have a collection of things above a line and something below a line. So these are the things we have. So we have x, y, z, f, g, h1 and h2, and we're trying to find t8, which states that the composition of g and f is continuous. Note how the write-up has started generating text. So the next move is to expand out the definition. So for all epsilon and greater than 0, and for all x in x, there exists a delta greater than 0, such that for all y in x, the distance between x and y is less than or equal to delta, implies that the distance between g of f of x and g of f of y is less than or equal to epsilon. Let's see how the proof continues. So we put epsilon above the line and x, and now we're going to expand out these hypotheses to the same thing. Next, we are going to take our existential quantifier and unpack it. We've put a delta below the line. This is because we need to find a delta which makes T12 true. The next thing we are going to do is finish off unpacking our expression, our target. We've put y in a special box because we know that y can't depend on delta. Note here how we have two extra rules which you can apply, which are relevant to metric spaces. So for instance, if we're trying to prove that this is true, then that's the same as trying to prove that it's true with the argument swap round, for instance. What happens now? Well, we can see that we're going to have to use h4 on T16 by looking at this. So I'm just going to apply a move which makes these expressions more easily accessible by the prover. Don't worry too much about this. The diamonds just mean we can replace the x with anything we like, and this thing will still hold true, provided that we can prove this. Okay, so we can see here that T16 is going to match with H15. If we use x diamond as f of x and y diamond as f of y, and we can replace epsilon diamond with this epsilon here, then this will match with this. So if we want to prove this, it will suffice to prove this, where x diamond has been replaced with f of x as before. But we would also be given a new constant, which we'll have to rename because this delta clashes with this delta. So let's perform that move now. What happened? We used H15, and we have this new constant eta, which came from here, and now we just have to prove this. But since we've replaced x diamond and y diamond, we get this. We can do exactly the same move with H10. This matches with this, and that completes the proof. The proof state went away because we ran out of targets. Now look at the write-up. It's a natural language representation of the proof, which wouldn't be out of place in a textbook. My goal is to make more and more proofs accessible by automated reasoning in a way that lets you generate natural language write-ups in this way. Thank you for watching.